Okay, welcome to the Carpenter Working Group for September 11th, 2025. Let's go ahead and get started. From the AWS side, at least, we don't have any major project updates to announce today. Does anyone else from like any of the other providers have any updates they'd like to add? Okay. Yeah, Omika.
Yeah, sorry, I was slow on the raise hand function there. I guess it's probably worth noting that today at the SIG Autoscaling meeting, which was a couple hours before this, Josephine Pfeiffer gave a demo of the IBM Cloud Carpenter provider. So if anyone's curious about that, there should be a recording of it. I don't know when it'll be online, but hopefully today or tomorrow. And then I think it sounds like that she's going to try to propose that project for hosting by SIG Autoscaling. So I don't think it necessarily changes anything here in this meeting, but for folks who might be interested, it seems like the IBM Cloud Carpenter is kind of moving along.
Okay, awesome. That's good to hear. Okay, anything else anyone wants to discuss, or do we want to move on to RFCs? Okay, any RFCs anyone wants to raise? There aren't any in the doc, but if anyone wants to raise them now. Okay, if not, community questions then. So, Max, are you in the call?
Yeah, thanks. So basically, I think a few months ago or a month ago, there was this issue where brought up in the SIG where we want to have a maximum number of node claims or nodes that Carpenter can provision. And I think discussion got sort of stalled here uh, in the issue. I'm just wondering like what's sort of the best way to push this forward. I think yeah, Reed there said that there might be RFC for this, but I noticed that there's this PR that I also linked that got closed as stale that would seem to fix our issue, which would involve having like a global configuration for this. I'm wondering if maybe if it would be possible, like if someone or me could open this or reopen this and try to push this forward.
I think we do need an RFC, and the reason I say that is we're adding, for static capacity support, we're adding node limits, and we were investigating what it would take to just expand that to dynamic capacity. And you get some really, I guess, undesirable interactions with things like drift, consolidation, etc., because all of those would typically expect that you're able to burst over those limits. Um, I think before we accept just like a global max node claims cap, minimally we'd want to see an RFC kind of outlining what the possible integration with something like drift consolidation, etc., looks like. Whether that's a different mode to those features, which allows you to not burst over, or like some max burst semantic. I'm not prescribing like a particular approach we would need to go for, but it's just like a set of options I think we would want to explore. Adding just a hard cap isn't really desirable because of how it breaks support for those features. And I think that would be surprising to a lot of users.
Got it. Fair enough. Um, okay, then I guess the best path forward here is to open RFC, and that would show like how we would integrate this new feature with the existing functionalities. Is that correct?
Yeah, I think so. And I can go ahead and leave an update on this issue with what I just said.
Awesome. Okay. Thanks, Jason.
No problem.
Got a question. I think I had set node as a max before, and I think at a certain point it stopped.
Oh,
And
sorry.
I'm not 100% sure what happens to all the other functions when you hit the node max limit in your node pool. I
You
think it
muted
eventually
like
stopped
half
creating
of
new
what you were
nodes.
saying.
Sorry?
Yep. You muted for like half of what you were saying.
Oh gosh. Yeah. So in the node pools, I think you can technically put a node as a limit, even though I don't think that was officially supported. I know eventually you run out of capacity, I think on provisioning on launching nodes. But I don't know what happens to every other controller when you do that. I don't know that feature's expected or that behavior is expected, but yeah.
So to support drift and consolidation, limits today are kind of treated as a steady state limit. Like you can burst over limits because of drift and consolidation.
Right, okay.
If we wanted to introduce more hard limits, I think we need, which I think is what this issue is asking for. Someone can correct me if I'm wrong, if soft limits are all we care about. Um, but if we want to introduce hard limits, whether that be for nodes or for any other resource, we need to think through the interaction with those other mechanisms.
Uh yeah, I guess max, I haven't read through it. Do you want a hard limit? I think, yeah, that'll be interesting. Okay.
Yeah, because I think it is good to call out that, I mean, while it's not like something we explicitly added support for, I think the existing limit model does support soft node limits.
Yeah.
Um, but yeah, just not hard. Yeah, Omika.
Remind me, Jason, did we settle on static capacity limits being hard or soft?
Static capacity ones are hard.
Okay.
So hence why there's a little bit of skew between how it works with static capacity and node overlay.
Yeah.
So yeah, I just wanted to add a little more detail, kind of like giving a little more context to where we're coming from on the request for this, because Garvin, you're right. Like the node limits in the node or a limit on nodes in the node pool could be used, and I think Max did do some research into that as well. But there's kind of a bigger problem here, right? Which is like imagine I'm a service operator, right? And I'm designing a new service that's going to use Karpenter at the core of it or something, right? If I want to create a global like node limit for that, to do it using the node pool maximums would mean that I would have to like be aware of all the node pools that like potentially a user is creating, and then I would have to like enumerate them, calculate the maximums, and then somehow like reject node pool submissions that that push that maximum out. So having like a really simple way to set at a global level, just say, hey, look, this carpenter can never make more than 500 nodes or whatever, right? And for whatever reason, like there's a lot of good reasons why you might want to do this, but like having that as a global limit is going to be a lot easier to deal with than having it as a per node pool cap. And especially as Jason says, if those are soft caps, that definitely colors the way that works, I guess.
Got it. That makes sense. Okay.
Yeah, and I think that's a similar reason to why we decided to do hard limits for static capacity. Since the static capacity feature was alpha, I think we know that there's some more fleshing out to do about how these hard limits interact globally with Carpenter. But yeah, I think people saw the uh, I think EKS Ultra Cluster announcement. I think we had talked about it a little bit a few weeks ago and how we were using Carpenter to do that scaling, and we can't drift that many nodes and have it double. That would knock over networking infrastructure.
Right. Yeah. I think networking is probably one of the key use cases here, right? Like if you're provisioning infrastructure for like, for customers potentially, and you have a limitation on the size of the IP block that you can give them, then yeah, like you're limited very physically by how many nodes you can create, right?
Yeah. Yeah, so I definitely agree. I think there's a very valid use case for this feature. I think it is just something, if we see an RFC for it, we can start moving from there.
Yeah, that makes total sense to me.
Makes sense. Thanks.
Okay. Anyone have anything else they want to discuss on this? Okay. If not, Garvin, looks like you have a couple of points. Oh, no, this is just
No,
details, huh?
yeah.
Okay. Sam, do you want to discuss this?
Yeah, sure. So, I did actually join this, I think this working group probably about a yearish ago. And so we have actually adopted Carpenter fairly widely at Pinterest where I work. And one of the things that we are still trying to work through is how we can do disruption handling for different edge cases that we have. So we are aware of the do not disrupt annotations for nodes and pods, and you're able to have a termination grace period seconds on the nodes. So our problem with that for solving this issue, and I see this is still open, but people are suggesting that that solves it. But what we're experiencing is that we have some pods that we want to not disrupt for longer periods than others, and there's no way to do that today other than dedicated node pools. I think it would be ideal if we could have the pods specify how long they want to wait before being disrupted. So that's one, and I think this is potentially something that's still open. And then two is that we're exploring about having disruptions for more stateful workloads, and we're trying to think about how it makes sense to handle um, what should be at the layer of, say, an operator and what should be at the layer of Carpenter itself, and how involved Carpenter should be with the disruption for these stateful workloads. So I think we're interested to learn just about the Carpenter project's overall thoughts on workload aware disruption and just effectively what the state of the art is and just the team's thoughts in general. We may be interested in contributing along these lines in the future.
I mean, I have a couple questions off the bat. Does a time
Just that you
semantic make
described, I
them?
think. Hmm?
I have a couple questions off the bat. Does a time semantic make the most sense for you, or is it more of a disruption costs kind of semantic that you're interested in? Would either work, or because it sounds like you want finer grained controls over when pods get disrupted and which pods get disrupted?
Yes, we do. What does cost mean? How would that work?
Like when Carpenter's currently calculating what nodes to disrupt, we calculate an overall disruption cost for that node. The calculation is pretty naive right now, but if you had the ability to configure pod sets with like this pod costs X, I don't want to get too nitty gritty on like what the cost indicates, but basically try and tell Carpenter like these pods are expensive to disrupt and these pods are cheap in some kind of weight mechanic some form, would that satisfy your need of having then Carpenter choose to disrupt nodes with pods that have overall less of a disruption cost, or do you actually need like a time limit? Like this pod should not be disrupted for 10 minutes.
Yes, I think weight or cost is also one of the features we were thinking about, but I think we do explicitly want the time functionality because we have some workloads that have some sort of max bounded time that they should be completed by. So I think the time semantic would be important, but also I think we would also like some prioritization among different running workloads, sort of like you're saying. I'm not sure how the cost is determined other than my understanding is it's just the priority of the pods, right?
Well, in this case, it would be the priority of the nodes given what pods are on them. But yeah,
Yeah, basically what Derek's referring to is like in consolidation, it's part of the weighting for like which nodes do we evaluate first based on the pods which are scheduled to them. And this is a function that combines quite a few different factors, like how long the pods have been running for, how many pods are on the node, etc. So it's basically just a heuristic for us to be like, if we're choosing between nodes A and node B, which one is less disruptive to the cluster? Though to Derek's point, this heuristic could improve a bunch.
Yeah, I think we're interested in that functionality. I don't know that we have an immediate use for that. I think part of the heuristic already is the priority class, is my understanding. I think we can use that to have some influence over it. but I think we're more interested in having this sort of time semantic on do not disrupt so that we can say have a node with a termination grace period of say 7 days, but we can have a pod that says don't disrupt me for 3 days and then go ahead and terminate. So then other pods can schedule for shorter or longer based upon what they're expecting their maximum time to completion would be. This is generally for jobs.
Yeah. I do think just initial impression that use case makes sense to me. Um, I think if we could just get like a short RFC with some examples, um, the big thing I'd be interested with is how that interacts with something like termination grace period, and basically just some codified examples of why this meets your use case versus the existing mechanisms don't. I think it seems like you've already thought that through, so I'm hoping
Right. So it should
writing that out
be
won't be
the
too
time
difficult.
period should be bounded by the termination grace period on the node. So it should strictly be that or less.
Yeah. Yeah,
I
I think if
guess. I'm sorry, go for it.
no, go ahead.
I'm trying to understand the use case. Like, so you're saying the pod, I guess like the eviction itself is not like technically done. Well, the API call is done by Karpenter, but you're saying don't send the eviction API call to the pod until after the pod's termination grace period? Or
Mm,
because in theory, the eviction is like the eviction won't force itself through until the pod is itself terminates. So you can hold on to the eviction as long as you want before the pod dies. The, I guess you don't want that. That's not good enough. Is that the case?
So what I'm talking about is very much like how do not disrupt works today, except instead of it being binary, true or false, it would allow you to specify a time. So yes, I think there's some uncertainty about exactly how this should be implemented because there is also the termination grace period seconds for the pod, like you're describing. My
Mhm.
understanding is that you don't want to have a pod's termination grace period seconds set to, for example, 3 days. I have seen some general guidance that it should be something relatively short. The default is, I think, 30 seconds.
Mhm.
And I think we probably want to reserve that actual pod termination grace period seconds for, I would say, I'm trying to remember what the terminology is in Carpenter. It's like a involuntary disruption, I believe. So something where like the node is actually wrong and you need to clean up now and evict. So if you set the termination grace period seconds, the normal kill behavior to wait for the job to complete when actually the node is messed up, you don't have a way to force it through other than forcibly deleting the pod. So I think it makes sense that we want the job to still have this sort of involuntary termination behavior, but to for these voluntary cases like drift, we want to delay that disruption. So that's what the do not disrupt annotation does, and I think that's what we want to be more flexible.
Got it. So I guess what happens, like the node will be like, we want, or we're interested in killing the node, but then we're gonna wait a bit until we can kill each of the pods when it's ready to, and then eventually kill the node kind of thing,
Yes.
right? Yeah, okay, okay, okay. Okay. And I guess at a high level, okay, let me think about that. That makes sense then. Thanks.
Yeah, so I think this issue is the most close thing to what we're talking about. So maybe we can leave a comment here describing our use case, and maybe that would be helpful. Or do you think we should go the path of RFC, or what do you think would be next steps on this?
I think if to get it merged into the project, an RFC would be the next best step. Just because then we have like a source of truth to compare against when like validating that a feature implementation meets the agreed upon design. It's just usually easier to drive consensus on that through like an RFC than it is through a GitHub issue.
Okay.
So yeah, I don't think it needs to be particularly long, just giving like some examples of this is why the existing controls, like this is the use case, this is why the existing controls don't meet that use case, and these are some possible either extensions to existing controls or new controls um, that would allow you to meet your use case.
Okay. And then, so I wanted to bring up as sort of a separate but related topic. So what we've been talking about is when you're scheduling the pod, if you already know how long the do not disrupt should be, you can specify that as the annotation. But there's another class of disruption here, which is that the pod doesn't necessarily know how long it would want to wait when it's first scheduled, something that's even more dynamic. So the example I gave, I think I shared in the doc, is if you have a stateful system and this particular pod is actually hosting the last replica of a shard of data, I think we would like some sort of way to indicate to Karpenter, like, hey, this is actually right now not disruptible because it is a critical pod. And if you terminate it, then we're going to have data loss. So I think there's a question about how we handle this sort of class of disruption generally. I don't know if there are existing work or solutions for this, because it seems like you would need some way for the workload to communicate to Carpenter for this.
Do you
I
have
think do
PDB
PDB
set?
possible? Yeah.
So a pod disruption budget doesn't really handle this. Or I guess if you had a pod disruption budget per shard, it could. Um, but the pod disruption budget usually considers each replica equivalent. When what I'm talking about is usually something where this particular pod has some critical piece of state that makes it unique from the other replicas.
Okay, so it's not like you just need to maintain some minimum quorum size. There could be a distinct set of pods within the group that need to be maintained. And
Yeah,
you don't get that with like a min pod available.
yeah, I think it's effectively the pod disruption budget is not dynamic enough. My understanding is you can only have one pod disruption budget for an entire pod. And I think in a lot of these stateful systems, there is more than one criteria of disruptions that they want to guarantee against.
And on the flip side of that, wouldn't it be when you want to disrupt them, like you want to update them, you want them all to update at the same time? So you're, uh, I don't know, that makes sense as well.
Yeah, so that's the Flink streaming case, I think
Yeah,
is
that's what
it's
I was thinking about. Yeah.
sort of like when you do ML training, in that when you disrupt a single pod, the whole job, so it's a bunch of pods across a bunch of nodes, they all need to restart from the latest checkpoint. So I think we're currently exploring if we can improve that behavior just from the operator for Flink. So I don't know if that's something we want to do at the layer of Carpenter or not. Uh,
Gotcha.
that's
Makes
something
sense.
we're looking into, yeah.
I'm just kind of thinking through these workload aware, like different applications having different needs and how granular do we need to be?
Yeah, I mean, that's where my gut feeling is in this case, because it seems like it's going to be very application specific, what the requirements are. It would make sense for an external operator to handle like the addition and removal of do not disrupt annotations. Um, it'd be interesting to hear more use cases though. Um, this isn't something I think that's been, at least not something I've looked into before. I don't know if it's been raised in the, or if anything similar has been raised in the working group yet.
I don't have a solution. I'm not 100% sure either that this fit in Carpenter, but we have similar issue, like you said. And our Flink team hacked PDB in a way where, because we don't rely on the readiness probe, they have a readiness probe that checks if the state of all the other replicas that it needs to be up is still up. If it's not, it forced the PDB to be like, everything is unhealthy, don't delete anything, as a hack to kind of protect the last shard in a way that PDB doesn't really do right now. I'm not saying that's a good solution, but at least that's what they're doing right now because the limitation of PDBs. But this is a still interesting, good use case. I just don't know what Carpenter can technically do. Yeah.
Yeah, I think this is something, if we wanted to investigate like some form of native support in Carpenter, I think we would need a fair few examples of different types of workloads to make sure we're coming up with a generic solution. Um, yeah, my gut feeling right now is that like dynamic addition and removal of the do not disrupt annotation by something external is, at least in Carpenter today, the best way to support your use case.
Yeah, I think we can do that. I think if we add the time to the do not disrupt, that would especially make it more powerful. Uh,
Mhm.
so maybe we can just go with that route for now. I don't know. So I have some other people from Pinterest here. I don't know if any of them want to speak up about our use cases.
I didn't want to cut in line. I actually have a slightly tangential but different question, two rows down from here.
Well, I think I'm pretty much done with this. I don't think there's much more to talk about necessarily.
Yeah, I think just an intro, uh, for fairness, we get to Cameron's and then we can get to yours.
Absolutely.
So, yeah, Cameron. Um,
Yeah, the background of this one is about node labels and Carpenter managing restricted node labels. Just asking because I don't really understand what the status of this PR is in. Did it still need another review, or should somebody interested in moving this along just try and re-implement this based on the existing PR and rebase it? Because it had a lot of discussion, and this was discussed in a previous meeting a couple months ago. Um, uh,
yeah, I
El
think,
Miko, I know you're here. If you have any context you can add.
Yeah, I mean, unfortunately, not really, aside from what's going on in the PR. Like it looked good to me. Like, I think, like I said there, yeah, just kind of waiting to see if any of the maintainers agree or, don't
If
want
it
to
if
see
it
this
just needs a
implemented.
rebase, like I can take a look at this and create a new PR with the rebase of it. But I wasn't clear if that's what all it was needed or if there was some sort of more review.
yeah, yeah, I think, well, either Jonathan or myself will have to review it for just the approver. Um, yeah, I can check with Jonathan since he had assigned it to himself. This hasn't been on my roadmap, but I will go ahead and take a look at it if he hasn't been able to.
Cool. Okay. Thanks.
Yes. And
I don't really want to waste more time on this if there's something else.
I maintain my position from April 16th.
So I will go ahead and assign it to myself so I don't lose this. But okay. So yeah, we'll follow up on that. And then yeah, turning off Carpenter disruption handling.
Um, Hey, I also work with Sam at Pinterest. So this is a slightly different use case for our CI/CD system. So we've been looking into doing software upgrades on our nodes more frequently. We've historically not done a great job of this. And so we want to do CI/CD pipelines for node upgrades, which looks like essentially a CI/CD pipeline updating Carpenter node pools, for example. Now, one of the issues we have right now is we have no way to um, slow down or stop Carpenter's drift and consolidate. So we rely on drift to actually do the actual node replacements, but we don't have any way to kind of signal at a cluster level to say stop drifting because let's say we have internal metrics which show a new army that's rolling out is breaking stuff. The best we've been able to come up with, so that I wanted to bring up for discussion, is whether this is a reasonable approach and whether there's appetite for a cluster-wide feature. So one of the proposals we have is have a separate controller which runs essentially outside of Carpenter, but is as a node pool that is hooked into our internal metrics and then which finds out, let's say, based on a human pushing a button or based on internal metrics which indicate something's wrong, just updates the node disruption budgets to zeros, basically. And that would just stall Karpenter from doing any further drifts, essentially acting as a circuit breaker. What I wanted to ask is, first of all, is this a reasonable approach? And secondly, is there appetite for some sort of a flag in Carpenter's global settings, which allow us to, just stop all drifts temporarily?
I guess the one thing. Oh, gone.
Yeah, I was gonna add, we have something. So I'm not like, we use Carpenter here. I'm from Stripe. What I've done is, we have essentially a lock that's outside of Carpenter's own system, and when you turn on the lock manually or automatically, it goes and deletes all the consolidation and drift configuration from the node pools. But I think what you're saying makes sense to me, to be able to say cluster Y or a separate configuration that like essentially disable these kind of things for all the node pools. I think that would be a good to have, just because the node pool adjustment or changes dynamically is kind of hacky, it feels like. Yeah.
Yeah, I'm not saying I love it. That's basically all we came up with so far.
You could always put like an annotation on the node pools. If we were going to do this in Carpenter, I think the best way to do it would be to like add support for an annotation that does this automatically, and then whatever ripcord you have just marks that annotation as like a temporary like node pool, no drift type of thing.
Yeah, that
Yeah,
makes
But
sense.
honestly, like I would hesitate to see the difference between that and then just adding a budget to all the node pools. Like whatever script you have is going to do that anyways. The question is just, will it live in Carpenter or will it live in whatever repo you guys want it for? I guess if there's appetite for a bunch of people to use it, we can have it in the main repo. I think that makes sense. But
Sorry, can you expand on the add a budget? I don't think I fully follow.
oh, it's what you were suggesting we do here, or what you could do is you just set a budget, a disruption budget, like a no
Ah,
disruption budget of like 0% as your like ripcord.
What about the
ah,
idea of a node disruption budget for the entire cluster, like all the nodes the Carpenter's managing, rather than per node pool?
I don't know if we have anything configurable like that currently. You can imagine there's like a whole set of um, configurations that you might want to set at the cluster level here. Like no disruption budget, maybe there's a cluster wide one and a node pool one. I would hesitate to add a cluster wide one just for this use case. Like if we're going to use that, if we're going to add that, I would like to know a bunch of the use cases and how they can't be um, satisfied with like node pool level constraints.
I
I'm
do
not
think
opposed
there's
to
a
it.
few
It's
we've talked
just
about just today, like cluster-wide limits, for example, both hard and soft. But yeah, I agree that like if we wanted to add some cluster-wide, like dynamically reconciled configuration, I think it would make sense for us to try and come up with a more comprehensive solution.
got it.
But yeah, I do think the way that I kind of agree with Derek that today it seems like I'd like to know what the pain points on just like adding a nodes zero budget to all of your node pools in response to this are.
So straight off the bat, the one thing I can think of is the node pools themselves. We'll usually deploy them through IAC, right? So we'll have somewhere in version control where we'll plug in the node pool information and then roll that out. Now you have a different actor mutating that resource outside of the what's in version control. Just not, it's fine, I guess. It's just like hopefully no one rolls forward and then overwrites it again, and then you're in that mess. So you don't.
Oh,
It would be
is,
ideal if there was a control outside of that.
is there a reason this change couldn't be rolled out through version control?
I think what the way I'm thinking about this as an operator is if there's an automated alarm that fires, I want the disruption to be set to 0 basically right away before even an engineer has come in and said what's wrong, right? Like stop the bleed and stop the rollout of this new node change or this new drift.
Okay, and you wouldn't want to have anything automated, like checking stuff in.
Correct. At least today we don't have that mechanism. All our check-ins go through human review.
Yeah, I guess to add some color, that's exactly the problem that we have with the thing we're doing, which is like essentially going through all the node pools and setting consolidation to 0. That mechanism is completely separate from the thing that deploys updates to node pool CRDs. So it's possible that that thing goes, locks everything, meaning turn everything to consolidation 0, but because the Omni system doesn't know, oh, I need to go and lock the deployment of the node pools. The deployment can still happen, reset the thing back to whatever it was before, and then our control will go back and relock it again. But that, I don't know, a few minutes that happens, things can happen in that few minutes where consolidation can happen. And I guess I think for most, I don't want to say for everyone, but I think like at least for us, the way we deploy, say, Kubernetes resources, it's usually a very different system than the thing that triggers and do an action based on alerts. And it's hard to push a change quickly through the normal pipeline of changing node pools configuration, simply because that requires checking in code and building and stuff like that. Whereas the emergent system, it reacts quickly and is able to do actions against these objects. And only because right now we are forced to touch the object to stop it. If we can change something real quick, like add annotations real quick, or some other way to stop Karpenter from consolidating, that would be great. That's not like necessarily updating node pools or stuff like that, just because the two systems are very different and they act on different timelines, if that makes sense.
Yeah, I think it does. Just for my own understanding, why is it different to like apply an annotation per node pool versus updating the drift? Is it just
Oh,
because it's not on the spec and it won't get reconciled over?
not
I
exactly.
don't know if that's that different. Sorry.
Yeah, for me, it's not that different. Like annotation is nice, but I don't. To me, that won't fully work for us, just because, yeah, like you said, annotation will get override on a deployment.
Okay,
So
got
yeah,
it.
yeah. I guess like ideally is a signal that Carpenter can somehow ingest that says turn off consolidation for things. I don't know, per no pull level or cluster level. I don't know, but at least that's what we're internally thinking. Like some way of doing that. We don't know the answer either.
Yeah. And yeah, to add slightly more color within Pinterest, we have our own upgrade controller, which we're trying to actually replace with Carpenter. And this is probably the one thing that that thing does, which is by itself through this additional configuration, which is why we brought it up here.
And actually, it has customizable weights based on the workload, but we have a lot of coupling with that configuration.
Right.
Yeah, so the
Yeah,
challenges here are right now Carpenter doesn't consume any signals from anywhere besides the custom resources that are in Carpenter that I'm aware of. That in like node status and pod status and stuff. So you'd be building like a new mechanism to get like live data in.
which, I mean, we've had it before. Settings used to be consumed from a global config map. Um, I think we just changed that because it was a little bit confusing to have settings change on the fly. Whereas this is intended behavior.
Also, I hesitate to like if this is going to be a cluster-wide thing, like a ripcord. We have like a a cluster object that you put this information on. I could see a future in which we end up creating people end up creating cluster configs that are deployed through CI/CD deployments, and then we are back at the same problem where you can't update that object
Yeah.
live.
I would say like, yeah, I agree. Like, I don't think a cluster object is the way to go. It would be interesting to see with the auto repair or the what's ARC's auto recovery controller integration with Karpenter, if there's something that opens up an interface that can kind of inform Karpenter of like, there's something going wrong, we should stop, or replace notes, like we should stop doing certain things and use that as a way to interface the signal rather than, yeah, like you said, an object.
Well, as far as that goes, we kind of have an existing signal for that, and that's the like readiness probe, which can inform PDBs. So I know you had mentioned in the issue, like this is my first time looking at the issue, so I just skimmed it to get some context for this discussion. But I know you had mentioned that like, yeah, the black and white failure case of the pod isn't healthy or the nodes aren't joining, that seems to be covered fine. It's more of this gray failure case where like performance may be degraded.
Yeah.
Would it be possible to like basically have that performance check within a readiness probe, or is that just too expensive?
Yeah, so today I, I suppose I think it might be possible. I don't think that's just how a majority of our workloads are set up. So it'll probably be a really expensive setup.
I don't think you want
Also,
to.
yeah,
Yeah, I
sorry.
don't think you want to mark a whole pod as not ready just because it's performing less than it used to.
Yeah, I think that has more consequences on availability as well. Um,
Oh yeah, I suppose because now it's no longer being served by services and such.
yeah.
No, that makes sense. Yeah, I don't think we're going to be able to commit to any concrete solution today. I do think the use case makes sense. I think the biggest concern I would have with us just like adding a config map and reconciling off that is that that config map, well, A, to the point that was already brought up, people will start managing that with GitOps.
Yep.
But B, I don't want to see us just have like a grab bag config map with a bunch of different global overrides. That doesn't seem like a great user experience. But I do think the use case makes sense, and it would be good for us to explore the different options that are available.
That sounds good. And I think at least we have a interim solution which we don't love, but that's fine. For this request, how would you like to proceed? Is there would this be research that y'all would like to do a little further on this? Is there something you'd like as a requester for us to do as well?
Um, I don't think we could make any commitments to picking up development on our own roadmap. I think it would be something given an RFC. I mean, we would review an RFC if it was provided. And then could go forward with feature implementation if we agree on an RFC solution. I mean, I think Derek, are you the only other one on the call from the maintainer team?
I haven't looked at the list, but probably.
Yeah, I think I mean, what are your thoughts on the reasonability of it? And to me, it seems like a reasonable use case.
Oh, absolutely. I think there's like deployments here, automated, stopping and rollback is like a
Yeah.
tier 0 availability feature for any CI/CD system. So if you're using Carpenter to do CI/CD, like you're going to need that, right?
Yeah. Yeah, so I think consensus from two of us, it seems like it's a reasonable feature. So I would say go ahead with an RFC.
Okay,
Or
sounds
at the
good.
bare minimum, like an issue with some alternatives, and we can talk about it in the next working group meeting and maybe like get some more folks going and like narrow down the ideas of like where we want to go. Just like a broad high level, like here's a bunch of alternatives that we could do, do it through a script that updates no disruption budgets and like how do you prevent deployments? I would like to know, I don't know a lot about all the like CI/CD systems that people use to update Kubernetes objects, so some additional background there would be nice as well.
Yeah, that was the background I was hoping to get in an RFC. So whether it's that through that or if we would just want to start it with discussion in the issue, either seems fine.
That makes sense. I can take that. I can try to craft an RFC on site. I'm not sure. I will try and get it ready in time for the next working group meeting.
Okay, sounds good. Thanks for raising this. Okay. Anyone else have anything they want to discuss? We're at the end of everything that was scheduled. So,
So I wanted to ask for the dynamic do not disrupt annotation. Is there a doc on the RC process? How we get started creating that?
we definitely should create one. I don't think we have a formal doc today. What we do have is examples.
I just saw under designs there's some docs. So just
Yeah,
a PR creating another one in here.
yeah. So the designs one would probably be a good one. Like, um, maybe not the no schedule taint, but I think the termination grace period one was pretty well done. Um, I don't know. It's one of the ones in here.
Node
So,
claim looks like starts with node claim termination grace period.
yes. Yep, the one my mouse is hovering over. So, yeah, this I think it would be good for us to have like a formal doc saying like this is the requirements for an RFC, this is the structure they should take, etc. But yeah, right now I think just leaning on examples.
All right, may I ask a question on the design of it actually? So would it be okay for do not disrupt to be Boolean as it is today or to be a time like a 24H like you have there on termination grace period, or should that be a separate annotation?
Um, I think that would be alternatives that could be proposed. I'm trying to think. I don't, I think that would potentially break existing configurations because I don't know if we change the field to like a string.
Well, it's an
Um,
annotation, so it is a string, just whatever interprets it, right?
oh, that is, I think, a good point. So yeah, no, probably that would probably be okay. I mean, I would like to see us not need to add another annotation. So if we have a good solution that can keep the same annotation, that would be good by me.
Okay. Yeah, I'll put something, I'll put a PR in here for that.
Yeah. Anything anyone else wants to raise? Okay. If not, we will go ahead and end 8 minutes early. Thanks everyone for coming.
Thanks. Later.
Thanks for your time.